Hello, this is Dr. Hanaa Assil, and this is paper 1C of the Pearson Edexcel International GCSE. This was the paper for May-June 2023. So let us take a look at the questions and discuss the answers. The first question in this exam was the box gives some methods that are involved in the separation of mixtures. Use words from the box to identify the method involved in each of these separations. Now, he's saying give the best method for obtaining gasoline from crude oil. Well, you should remember that crude oil is a mixture of liquids. In order to separate its constituents, we need to do fractional distillation. So we do fractional distillation of petroleum or crude oil in a huge fractionating column and obtain the different fractions based on differences in boiling point. So the one with the lower boiling point, that is the compound that has less number of carbons, is collected at the top of the fractionating column. Okay, so that is fractional distillation. Now the next question is about the best method for separating dyes in black ink. Which method do we use to separate the different colors in ink? Well, this is chromatography. Give the best method for obtaining pure water from seawater. So if I have a solution and I want the pure water, we use simple distillation. This is simple distillation, in which the water evaporates, boils at its boiling point, goes into the condenser, and it is cooled and condensed in the condenser so that it's collected as pure water. A sample of solid hydrated copper sulfate can be obtained from a mixture of copper oxide and copper sulfate. So we have two solids, copper oxide and copper sulfate. We're trying to separate them in order to get the solid copper sulfate. So what do we do first? He says the mixture of copper oxide and copper sulfate can be separated by first doing what? Well, copper oxide is a black solid, copper sulfate is a blue solid. They are both solids in the beaker, so first I need to dissolve the copper sulfate in distilled water. Then the copper oxide, which will remain as a black solid, is removed by filtration or filtering, because we're choosing, remember, we're choosing the words from that box. Some of the water from the copper sulfate solution is then removed by evaporating. So we do crystallization or evaporation to get a pure sample of hydrated copper sulfate by crystallization. Okay, question 2 says, this question is about the reactions of iron. Iron rusts when exposed to water and oxygen. Give the chemical name of the compound that forms when iron rusts. Remember, iron as a pure metal, it is silvery gray color like the other metals, but when it is exposed to the air, it rusts. Now, what does the air contain that the iron reacts with? Remember that the iron, in order to rust, it has to have both water and oxygen. So it takes water vapor from the air, oxygen, and it becomes hydrated iron 3 oxide. So this is what we call rust. So the chemical name of rust is hydrated iron 3 oxide. What type of reaction occurs when iron rusts? So if we have iron reacting with oxygen, what type of reaction is that? That is an oxidation reaction. Galvanizing is a method used to prevent iron from rusting. So if we don't want the iron to rust, we need to do what? We can either paint it, cover it with paint, or cover it with oil to prevent it from reacting with water and oxygen in the air, or we can cover it with a layer of zinc, and that is called galvanizing. So to galvanize the iron, we cover it with a layer of zinc by dipping or spray. That's what we call galvanization. When iron reacts with dilute sulfuric acid, the products are iron 2 sulfate and hydrogen. Give a chemical equation for the reaction. Again, remember, if the question needs chemical equation, that means it has to be symbol, not words, and it has to be balanced, even though he didn't say balanced, but it has to be balanced. So, what are we reacting? Iron with sulfuric acid. You should know that sulfuric acid is H2SO4. To give what? To give iron 2 sulfate. So the valency of iron is 2. The valency of sulfate also is 2. So we do not put 2 under any of them. Plus hydrogen. Remember that hydrogen is diatomic. That means if it's alone, you should put a 2 under it. Then we have to check, is this balanced or does it need balancing? We check the number of each of the different elements before and after the arrow. Well, this reaction appears to be balanced. 1 iron before, 1 iron after, 2 hydrogens before, 2 hydrogen after the arrow, and the rest also are balanced. Give a test for hydrogen gas. What was the test for hydrogen gas? You should remember, we said, insert a lighted splint, it pops. A lighted splint, not glowing. We said oxygen needs a glowing splint. Hydrogen, we say insert a lighted splint, it pops. An excess of iron is added to copper 2 sulfate. Name the type of reaction that occurs. If I put iron in a solution of copper sulfate, what is happening? The iron is more reactive than copper, so it will displace the copper and it will change the solution into iron 2 sulfate plus copper. This is a displacement reaction. State the appearance of the solid that forms. Well, what is forming is copper. What is the appearance of copper? You should remember that all metals are silvery gray in color, except copper, which is a reddish brown solid. So the reaction is forming copper. That means what we see is a reddish brown solid. Give the reason why no reaction occurs when iron is added to magnesium sulfate. So, they added iron to copper sulfate and it reacted. But when we add it to magnesium sulfate, you should realize that iron is more reactive than copper. So, it will displace the copper, and that is why it turned into iron sulfate plus copper. But iron is less reactive than magnesium, so it cannot displace it. So we cannot say iron plus magnesium sulfate. Why? Iron is less reactive than magnesium and cannot displace it. Question 3 says the table gives some information about 3 substances X, Y, and Z. So X has low melting point. You should know that anything that has low melting point does not conduct electricity at all, must be a covalent compound. So the type of bonding is covalent and the type of structure is simple molecular structure. So that applies to any substance that has low melting point and does not conduct electricity. Now, if substance Y is something that has high melting point, but it does not conduct electricity at all, again that must be covalent And because it has high melting point, then this structure must be giant. So we're talking about something like diamond or silicon dioxide with giant covalent structure. So it would have high melting point but does not conduct electricity. What about Z? Z has high melting point. It does not conduct electricity when solid, but conducts when molten. Now, the only substance that conducts electricity only when molten are the ionic substances, and the structure of any ionic substance is a giant lattice with alternating positive and negative ions. Explain why substance X has a low melting point. If the question says, why does anything have a low melting point? Remember, anything that has a low melting point must be a simple molecular substance or simple molecular compound. So this could be something like carbon dioxide, water. All the simple molecular substances have low melting point. This is because there is weak attraction forces between the molecules. We're not talking about the bonds inside the carbon dioxide or the bonds inside the water. We're talking about the attraction forces between molecules. If the substance has low melting point, then there is weak attraction forces between molecules, and this needs a small amount of energy to be broken or to be separated. Question 4 says ethene, which is C2H4, is a member of the homologous series of alkenes. Give 2 characteristics of a homologous series. Remember, when we were talking about organic chemistry, we said we divided the compounds into groups. Each group is a homologous series. That is a group of organic compounds that have the same what? That have the same functional group and the same general formula. So we said examples of homologous series, we said alkanes is one group of organic compounds, so that's one homologous series. All of them have only single bonds, so that's the functional group, and the general formula is CnH2n+2. That means the number of hydrogens is always twice the number of carbons plus 2. Alkenes are another homologous series. All of them must have at least one double bond between carbon atoms, and the general formula is CnH2n. That means the hydrogens are twice the number of carbons, and so on. So these are the different homologous series. Each homologous series, the members must all have same functional group, same general formula. If we want a third one, we say similar chemical properties. They will do the same types of reactions. Draw a dot and cross to show the bonding in a molecule of ethene. He already mentioned that ethene is C2H4, and you should know that anything that has eth is something that has 2 carbons. Ene means it has a double bond, and that means the number of hydrogens is twice the number of carbons. So how do we draw the dot and cross of ethene? To draw the dot and cross of anything, you write the symbols. So we are saying it has 2 carbons and 4 hydrogens. Now we need to distribute the electrons. Hydrogen, each of these hydrogens has 1 electron. So it needs 1 more because this is the first energy level in the hydrogen that we're talking about. So we have for each hydrogen, 1 from the hydrogen, 1 from the carbon. And then if we look at each carbon, you should realize that carbon is in group 4. It has 4 electrons in its outermost shell. So it needs 4 more to have a total of 8. Now it took 2 from the neighboring hydrogen, so it needs to take 2 from the carbon next to it. So there is 2 pairs of electrons being shared between the 2 carbons, in addition to the sharing with the other hydrogen atoms. Then the next question says, propene, which is C3H6, is another member of the homologous series of alkenes. State why the empirical formula of all alkenes is CH2. Well, you should remember that alkenes have double bond between 2 of the carbons. So, and you know that each carbon must have a total of 4 bonds, because each carbon has 4 electrons in its outer shell, so it needs 4 more. So each carbon needs a total of 4 bonds. So if we draw ethene, propene, butene, and so on, we find that the number of hydrogens is always twice the number of carbon atoms, and that is why the empirical formula is CH2. And we said that the general formula was CnH2n. So that means that the hydrogens are twice the carbons. Propene can be polymerized to form polypropene. Draw the displayed formula of propene and the repeat unit of polypropene. So, how do we draw propene? You should know that prop means 3 carbons. En means I have a double bond between 2 of them. So, how do we draw it? And you need to make sure that each carbon has a total of 4 bonds, so you complete it with hydrogens. So, this is propene. Now, how do we draw the polymer? Well, to draw the polymer, you look at the 2 carbons that had the double bond. Where is the double bond? I copy it with a single bond, bond before and bond after, because I'm going to attach this unit to another unit before it and another unit after it. And then I look at each carbon that had the double bond. The carbon on the left had 2 hydrogens, so I put 2 hydrogens in the polymer. Now the carbon on the right of the double bond has what? It has a bond going to hydrogen and a bond going to methyl, so this is what I write. You could put the bracket and N, or you could leave it. That's it's okay, it doesn't make a difference. Okay, this is the structural formula of another hydrocarbon compound. Give the molecular formula and the empirical formula. What is the difference? Molecular formula means total number of carbons, total number of hydrogens. So in this molecule, what is the total number of carbons? I have 4 carbons and a total of 6 hydrogens. So C4H6 is the molecular formula. Now, what is the empirical formula? It is the formula showing the simplest ratio. So instead of saying C4H6, I can simplify this ratio, divide through by 2, so this could be C2H3, so that is the empirical formula. Okay, explain why this compound is an unsaturated hydrocarbon. So we need to explain what do we mean by unsaturated and what do we mean by hydrocarbon. You should realize that if this is said to be unsaturated, that is because it has double bonds between carbon atoms. Why do we say it's a hydrocarbon? Hydrocarbon means it has only carbon and hydrogen atoms. Describe a test to show that this hydrocarbon is unsaturated. What is the test for alkenes or the test for unsaturation? Remember, we said alkenes are the ones unsaturated. The test for that is add bromine water. It turns from orange to colorless, or we say that it is decolorized. Question 5 says, this question is about lithium and some of its compounds. A small piece of lithium is added to a trough containing water. So they're adding lithium to water. Remember that metals of group 1, like lithium, are reactive metals, and the reactivity increases going down the group. So all of them, if we put them in water, there is a reaction. Lithium is the least reactive. It's the one on top of the group. So it is the least reactive. It just gives what? What are the observations when lithium reacts with water? It will just give a little bit of bubbles of gas because it gives off hydrogen gas. But remember that he wants observation, so don't say hydrogen gas. Observation means what do we see? We see bubbles of gas, and the solid disappears. So the lithium solid disappears. Of course, if we put sodium in water, the reaction is more vigorous. So we get vigorous bubbling or vigorous effervescence, and the sodium, because it floats on top of the water, then the hydrogen gas that is coming out may catch fire. If we put potassium, potassium is even more vigorous, more reactive. So we have a very vigorous, could be explosive, and it gives a lilac color, because you remember potassium gives a lilac color when it explodes. A few drops of methyl orange are added to the solution in the trough. What did we have in the trough? We added lithium to water. So you should know that group 1 metals are very reactive. They react with cold water. And when we put it in cold water, what is obtained is the hydroxide plus hydrogen gas. So we get lithium hydroxide, and you should know lithium hydroxide is acid or base. Anything hydroxide is a base. So when I put methyl orange in a base, what color should I get? We should get yellow, because the lithium hydroxide is a base, or it is alkaline. An unlabeled bottle containing a white powder is found in a laboratory. Describe tests to show that the white powder in the bottle is lithium carbonate. So we need to do a test to show that it is lithium, and we need to do a test to show that it is carbonate. So what is test for carbonate first? You should know test for carbonate is add dilute hydrochloric acid, bubbles of gas that turn lime water milky would indicate the presence of carbonate. Remember that the gas given off is carbon dioxide, but here again we're writing the observation. So the observation is bubbles of gas that turn lime water milky. What is test for lithium ions? The test that we have is flame test. So we say do a flame test. Lithium gives which color? Lithium gives red color. You should be familiar with the colors of the flame test for these metal ions. Lithium carbonate has ionic bonding. What is meant by ionic bonding? Again, please don't say it is a bond between metal and non-metal. We know that ionic, we must have a metal reacting with a non-metal, but the ionic bonding is the strong electrostatic attraction forces between the positive and negative ions, or between the oppositely charged ions, because we have positive and negative, positive and negative. These have strong electrostatic attraction forces between them, and this is what we call ionic bond. When solutions of lead nitrate and potassium chloride are mixed, a precipitate of lead chloride forms. So already the question says solutions of lead nitrate and potassium chloride. So these are solutions. Now the lead chloride that is formed is a precipitate. So what are the state symbols? Remember, if something is a solution, we say this state symbol is AQ because it's aqueous. So the lead nitrate is a solution, aqueous. Potassium chloride is a solution, aqueous. Lead chloride, already we should know that it is insoluble in water, and even if we don't, the question says precipitate of lead chloride, so that means the lead chloride is a solid. And of course, any nitrate is aqueous, so potassium nitrate is aqueous. And any potassium salt is also aqueous. Give the formula of each ion in lead 2 nitrate. So if we want to write the formula of lead 2 ions, this is how we write it. Lead 2 means it has a valency of 2, and that means it has 2 positives on it. Now the nitrate, how do we write nitrate? Nitrate is NO3, its valency is 1, so that means it has 1 negative on the ion. Calculate the relative formula mass of lead nitrate. How do we calculate relative formula mass? We look at the periodic table and we add up what? We add up the masses. The masses means the big number in the periodic table for each of these. So lead is 207. Nitrogen is 14, and you should realize that we have 2 of them. Oxygen, the mass number is 16, and we have 2 times 3. Can you see that? So when I have NO3 bracket 2, that means I have 2 nitrogens and 6 oxygens. The total is an MR of 331. A student investigates the height of the precipitate formed when lead nitrate solution is added to potassium chloride. He already said that when we add lead nitrate solution to potassium chloride, we should get a precipitate. So he put 15 centimeter cubed of potassium chloride into a boiling tube, added 2 centimeter cubed of lead nitrate solution. This forms a precipitate. Remember that a precipitate means we added 2 solutions and we got a solid coming out of the solution like that. So that is called a precipitate. Allow the precipitate to settle and measure the height of the precipitate. Repeat steps 2 and 3 until a total of 14 centimeter cubed of lead nitrate solution has been added. The table shows the student's results. We have a table here and we have a graph, and it's already labeled, and all we need to do is plot the results on the grid. Remember that when we plot, we use small x's or we use a dot with a small circle. Please do not put just dot, dot, dot. Okay? Draw a circle around the anomalous result. What do we mean by an anomalous result? It is a result that is away from the rest. So this one, for example, is away from the others. The others are coming up in a straight line, and this is away from the line. When we have an anomalous result, we do not include it in the graph. So draw a line of best fit. Please, when you plot the graph, do not just join it as a curve and that's it. Most students do that. They plot it and they join as a curve and they move on. You have to read the instructions. Once we plot the points, how am I going to join them? Well, it says draw a line of best fit through the first 4 points and another line of best fit through the last 3 points. Make sure that the lines cross. So this is what you should have. Draw a line of best fit through the first 4 points, but we're going to ignore the one that is anomalous. Draw a line through the last 3 points and make sure that the lines cross. Give 2 possible mistakes the student could have made to cause the anomalous result. So we have a result that is away from the curve. What do you think happened? Or what mistake could the student have done? We said when we add the two solutions, we get a precipitate. And what the student is supposed to do is to wait until the precipitate settles down and then measure the height of the precipitate. What if the student did not allow the precipitate to settle? He just measured the height quickly without allowing it to settle. That means the height will be higher than what it should be. Or the student added too much lead nitrate. Again, they will have more precipitate. Remember that the point that was off was above the curve. That means he got a result that is higher than what it should be. So either the precipitate was not allowed to settle down, or too much lead nitrate was added, so it gave too much precipitate. State why the first line of best fit should pass through the origin. When we drew it and joined it, we joined it to 0. Why is it passing through the origin? Of course, if I don't have any lead nitrate added, then I will not have any precipitate. So a 0 volume of lead nitrate means no precipitate, so the point should go through the origin at 0 and 0. Use your graph to determine the volume of lead nitrate solution needed to react completely with the potassium chloride solution. Of course, the volume needed to react completely is the maximum on that graph. So you read from the graph the point where the two lines meet. This would be around 9 centimeter cubed. So you should put the value that you obtained from the graph. Question 7 says, this question is about the three halogens, bromine, chlorine, and iodine. Give the number of protons and neutrons in an atom of iodine 127. Remember that the number that is given in the question is the mass number. I need to go to the periodic table and check first of all for the atomic number, which is the smaller number. So the smaller number for iodine, or the atomic number for iodine, is 53. That means I have 53 protons. Now, the mass number given in the question may be the same as what you have in the periodic table, or it may be different. You use the one in the question. So in this case, the question is giving the same as the one in the periodic table. So to get the number of neutrons, how do we get number of neutrons? It is the difference between the mass number and the atomic number. So in this case, it is 74. A sample of bromine contains two isotopes, one that has mass number 79 with a relative abundance of 52.8. The other one has a mass number of 81. Its relative abundance is 47.2%. Calculate the relative atomic mass. How do we calculate the relative atomic mass? It is mass number of the first one times its abundance, plus mass number of the second one times its abundance. The total of the abundance is 100, so you divide by 100. This gives me a number. But then he says, give your answer to what? Please check the question before you move on. Give your answer to what? To 3 significant figures. 3 significant figures means I look at the number after the 9. It is only 4, so it is less than 5, so it is 79.9. Do you know how to round up a number? Please round up correctly. Aluminium reacts with chlorine to form aluminium chloride. This is the equation for the reaction. Calculate the minimum mass of chlorine needed to form 26.7 grams of aluminium chloride. We want to make 26.7 grams of aluminium chloride. He's asking for the mass of chlorine. What is the first thing we should do? When we are given a mass, I need to get the number of moles of aluminium chloride. Of course, number of moles is mass over molecular mass. So this gives 0.2 mole of aluminum chloride. Then we go to the equation and we relate the equation. We find that the equation says if we have 3 of chlorine, it gives 2 of aluminum chloride. So if I have 0.2 of the aluminum chloride, how much chlorine do I have? So it's 0.2 times 3 over 2. From the balancing in the equation, the number of moles of chlorine would be 0.3. What is the question asking for? Mass. Mass is number of moles times MR. Remember, we're getting, and actually the question gives the MR. So the number of moles that we get times the MR, that is the mass of chlorine that is required. A student mixes the following pairs of solutions. Pair 1, bromine solution and potassium chloride. Pair 2, bromine solution and potassium iodide. Explain how the student can use the results of these experiments to show the order of reactivity of the 3 halogens, bromine, chlorine, and iodine. Remember that if a halogen is more reactive than another one, then it will be able to displace it. So what we're required to explain is we're going to add the 2 solutions of each pair, determine if there was a reaction or not. If there was a reaction, then the halogen added was more reactive. If there is no reaction, then the halogen added was less reactive. So if we look at pair 1, we're adding bromine to potassium chloride. Do we expect it to react? Well, if you look at group 7, we said in group 7, the one up is more reactive than the one down. So the reactivity decreases as we go down. So we would expect that chlorine is more reactive than bromine. So it will not be displaced. So if I add an orange color of bromine solution to potassium chloride, the orange color remains, indicating that the bromine did not react. So it must be less reactive than chlorine since it did not displace it. But if we add pair 2, bromine is more reactive than iodine. So if we add it, it will displace the iodine, and what I have in solution now is iodine. So the colorless solution of the potassium iodide would turn to brown because iodine solution is brown, indicating that bromine is more reactive than iodine. So it displaces it to form iodine solution, and that means chlorine is more reactive than bromine, more reactive than iodine, because the question wants to show the order of reactivity of the 3 halogens. A student uses this apparatus to find the molar enthalpy change of combustion, delta H, for the liquid fuel pentanol. This is the student's method. Find the initial mass of the spirit burner and pentanol. Add 100 centimeter cubed of water to the copper can. Record the initial temperature. Light the wick of the spirit burner to heat the water. Stir the water until the temperature rises by 35 degrees Celsius. Extinguish the flame and immediately find the final mass of the spirit burner and the pentanol. State why the student stirs the water. Usually when we're heating something, we should stir it to distribute the heat evenly so that all the water is heated to the same temperature. So just why it is important that the students immediately finds the final mass of the spirit burner and pentanol. As soon as we finish, we should weigh it. This is because if I wait, then some of the pentanol may evaporate, and that means the mass that I weigh is not accurate. So we weigh it immediately to avoid loss of some of the pentanol by evaporation. The diagram shows the initial temperature of the water. Complete the table and give the values to the nearest 0.1. So you need 1 decimal place. What is the initial temperature from that diagram? You should realize that that is 15.9. What is the final temp? How do I know the final? Well, it already gives me the temperature change. So if I have a rise of 35, that means I add 35 to the 15.9. That gives the final temperature of the water. Show by calculation that the heat energy, Q, is about 15,000 joules. How do we get Q? You should know that Q is mc delta T. What is M? M is the mass of water. So M is 100, and remember that for water, density is equal to 1, so the volume is the same as the mass. So when the question says add 100 centimeter cube, that is 100 grams. So the M is 100, the C is a constant, it's given 4.2, and the temperature change, delta T, the question says there is a temperature rise of 35, so that is our delta T. Multiply all of them together, this gives about 15,000 joules. Remember that the answer for this equation is in joules. The table gives the initial and final mass readings. So we have the initial mass of the spirit burner pentanol, the final mass of the spirit burner and pentanol. Use your answer and the information in the table to calculate delta H in kilojoules per mole. And remember, delta H must have a sign. So how do we get delta H? You should know that delta H is Q over N. So we need to get N. What is N? N is the number of moles. The number of moles is mass over molecular mass. What is the mass of pentanol that we used? Well, we have an initial mass and we have a final mass. So the difference between them is the mass that was burnt. Divided by the MR of pentanol, the question already gives the MR of pentanol. Mass over molecular mass gives me the number of moles, which I can then put into the equation for delta H. And remember, when there is a temperature rise, and this is combustion and the fact that is a temperature rise all tells you that this is an exothermic reaction, so the delta H must have a negative sign. Okay, the formula of pentanol is this. Write a chemical equation for the complete combustion of pentanol. Complete combustion means what? Means we're going to react it with oxygen, and this gives carbon dioxide plus water. This is what we have when we do complete combustion. Then we have to balance. Okay, now before the arrow I have 5 carbons, so I need to put 5 carbons after the arrow. Before the arrow I have 12 hydrogens, so I need 2 times 6 after the arrow. But then if I count the number of oxygens, so how many oxygens after the arrow? I have 2 times 5, 10 plus 6, so I have 16. Before the arrow, I already have 1 oxygen in the pentanol, and that means I need to do something so that I have 15 O2 or 15 oxygens plus 1, 16. So 15 will need us to put 2 times 7.5. Instead of putting 2 times 7.5, I can multiply all through by 2 so that we don't have fractions. So 2 of the pentanol plus 15 of the oxygen gives 10 CO2 plus 12 water. This question is about different hydrated forms of sodium sulfate. A compound has this formula. How many different elements are there in the formula? Different elements. What elements do we have here? We have sodium, sulfur, oxygen, hydrogen. So how many different elements? I have 4 different elements. what is the total number of atoms? Now, total number of atoms, what do we have? 2 of sodium, 1 sulfur, 4 oxygens, 2 times 7, which is 14 hydrogens, and then I have another 7 oxygens from the water of crystallization, so my total number of atoms is 28. Another hydrated form of sodium sulfate has this formula. A student uses this apparatus to find the value of X, so we don't know what water of crystallization and we're trying to get it. Okay, this is the student's method. Find the mass of an empty tube, add solid hydrated sodium sulfate to the tube, find the mass of the tube and the hydrated sodium sulfate, heat the tube for several minutes, allow the tube to cool, find the mass of the tube and contents. And the first question is, describe what the student should do next to make sure that all the water is removed. So what the student did was, we heated the tube for a while and then allowed it to cool, measured the mass. So of course the difference would be the mass of water. But how do I make sure that all the water has been removed? In order to make sure that all the water has been removed, I need to repeat again. Heat again, leave it to cool, reweigh until there is no more change in mass. So if the mass becomes constant, that means there is no more water of crystallization left in the solid. Explain the role of the ice in the beaker. So this was the setup. We heated the sodium sulfate in order to get the water of crystallization to evaporate. And then we pass the vapor into a test tube that is surrounded with ice. So of course, what is the role of the ice? The ice is actually acting as if it's a condenser. So this is to cool and condense the vapor. Describe how the student could prove that the liquid collected is pure water. What is the test for pure water? Or we say the physical test for water? Heat to boiling. It should boil at 100 degrees Celsius. The table gives the student's results. Use the student's results to calculate the value of X. So how do we calculate the value of X? Well, we get the mass of the sodium sulfate alone. So the table has mass of empty tube and mass of tube plus sodium sulfate after we heated it. That is 19.38 minus the empty tube. So this is the mass of the sodium sulfate alone without the water. We also need the mass of the water. Now, how do we get the mass of the water? We have mass of tube and hydrated sodium sulfate and mass of tube and the anhydrous sodium sulfate. So it is the 23.88 minus 19.38. This is one method of getting the mass of water. Now we can do it as if we are getting empirical formula. So the masses of each one, what do we do first? Divide by the MR of each one. The numbers that we get, we divide by the smallest. This gives a ratio of 1 to 10, and that means it is sodium sulfate 10 watt. Question 10 says zinc reacts with dilute hydrochloric acid to form zinc chloride and hydrogen gas, and this is the equation. In an experiment, 20 centimeter cubed of hydrochloric acid containing 0.0036 mole are reacted with 1.3 grams of zinc at a temperature of 30 degrees Celsius. Show by calculation that the zinc is in excess. The question gives me the number of moles of hydrochloric acid, but then the zinc, we have it in mass. So I need to get the number of moles of zinc. Number of moles of zinc is mass over molecular mass. Of course, we look at the periodic table to get the molecular mass of zinc, that is 65. So the mass given over the molecular mass of zinc gives number of moles of 0.02. Then we look at the equation. Where is the zinc and the hydrochloric acid? The equation says that the hydrochloric acid should be twice the zinc. But is the hydrochloric acid twice the zinc? Well, the hydrochloric acid is 0.0036. If this is the number of moles of hydrochloric acid, then actually we need only twice of that. Half of that. We need half of that for the zinc. So that is 0.0018 mole. And this is less than what we added. When we calculated what he added, we got 0.02 mole. So he added 0.02 mole of zinc, but actually the number of moles of hydrochloric acid added needs only 0.0018 mole of zinc, and that means the zinc is excess. They added too much zinc. The volume of hydrogen collected is measured at regular time intervals. Curve A shows the results of this experiment. The experiment is repeated using 1.3 grams of zinc powder instead of granules. Granules means pieces. So if we use powder instead of pieces, is that faster or slower? You should remember that powdered has larger surface area, so that is faster reaction, and that means the curve for the new experiment would be steeper. But because we're using the same amount of reactants, we did not change the amount of reactants, then we will have the same final volume of gas. So that is the new graph for the zinc powder. In the original experiment, 20 centimeter cubed of hydrochloric acid containing this number of moles were reacted with 1.3 grams of zinc granules at a temperature of 30, and we got curve A. The student does 2 more experiments. So, after doing curve A, they repeated the experiment again, and we got, in one of these experiments, the student repeats the original method, but at a temperature of 20. Remember that the first one was at 30. Now, when we repeat it at 20, exactly the same method, but we repeat it at a lower temperature, that means that the reaction now is slower. Slower means the curve that is less steep. We did not change the amounts of reactants, so we still get the same final volume of gas. So at lower temperature, you should remember, molecules have less kinetic energy, move slower, so there is less effective collisions. The rate is slower, the graph is less steep. Since we use the same amount of reactants, then we have the same final volume of gas. Then, in another experiment, the student repeats the original method using 20 centimeter cube of hydrochloric acid containing less number of moles. Can you see? The original experiment, we used 0.0036 mole. That was the experiment in A. Now, when we use half the number of moles, then we should end up with half the number of, half the volume of gas. So, graph C is our new graph because half the concentration of HCl is used. So, half the volume of gas is obtained, and that means that the reaction is, the rate is lower, so the curve is less steep. Since there is less particles, less effective collisions. Catalysts can be used to speed up reactions. Describe how a catalyst works. Remember, when we have a catalyst, whether the reaction is exothermic or endothermic, the effect of the catalyst is to lower the energy of activation. So when we use a catalyst, we have lower activation energy. This is because the catalyst provides an alternative pathway that has lower activation energy, so the reaction becomes easier and faster. And that's the end of this paper. Thank you for listening, and please keep listening to the videos. Thank you.